Stop.
Hidden deep within the forests of northwestern Pennsylvania, an engineering masterpiece. The Kinzhou Viaduct soared 301 feet high and 2,053 feet across, and was once the highest and longest railroad bridge in the world. In 1882, General Thomas Kane, Philadelphia lawyer, decorated Civil War veteran, and president of the New York, Lake Erie, and Western Coal Company, had rich coal deposits south of the Kinzhou Valley. But his customers were to the north. Kane needed to cross that valley, or move his coal by way of a long and expensive route around nearby mountains. Kane needed a bridge. Paris-born Octave Chanute, chief engineer for the Erie Railroad, rose to the challenge. The man who would later help the Wright brothers to fly had a bold solution, a bridge unlike any the world had seen. Chanute contracted the Pennsylvania firm of Clark, Reeves and Company to design and fabricate the bridge. Adolphus Bonzano designed a wrought iron bridge using his Phoenix column, an engineering breakthrough that enabled tall structures to resist vibration and buckling. The bridge was prefabricated at Phoenixville near Philadelphia and transported to the site for erection. Once the sandstone foundation piers were in place, 125 men completed the construction in just 94 days.
Man.
3.5 million pounds of iron, and $275,000 later, the first steam-powered train rolled across, delivering General Kane's coal to market. The viaduct was an immediate sensation. It stood 24 feet higher than the Brooklyn Bridge and became an instant tourist attraction. Walking out on the bridge was the next best thing to flying. But by 1900, the locomotives and railroad cars hauling coal and timber across the viaduct had become larger and heavier. A stronger steel bridge was required. Using 6.7 million pounds of steel, held together with 895,000 rivets, workers erected a new bridge to replace the original. Two timber travelers worked toward the center, demolishing the old iron towers one at a time as the new steel ones were hoisted into place. 125 men, working 11-hour days, finished construction in 4 months. Bridge designer C.R. Grimm predicted his creation would last 100 years, and he was right. Grimm's design used roller expansion bearings, where the tower legs were anchored to the masonry foundation piers. This design allowed lateral expansion of the tower legs under temperature loading. But his failure to replace the original 1882 anchor bolts would have catastrophic consequences. For generations, freight trains loaded with coal, lumber, and oil roared across the Kinzhou Viaduct. Later, excursion trains brought sightseers and visiting engineers from around the globe to visit the majestic bridge. Since 1963, the bridge has served as the centerpiece of Kinzhou Bridge State Park. Engineers and skilled bridge builders are hard at work on a $12 million repair project to reinforce the aging structure. The workers decide to call it a day when the sky goes dark and the winds rush in.
An intense system of severe weather is moving into Pennsylvania from Ohio along the north by northwest track at about 50 miles an hour, producing spiral bands of thunderstorms. At the rate these clouds are moving, there's the potential for serious damage. We have a large mesocyclone in progress over north-central Pennsylvania. The counterclockwise rotation inside the thunderstorm measures 2.5 to 3.1 miles in diameter and extends from near the ground to an altitude of 3.1 miles, causing violent winds and heavy precipitation.
A tornado tears through the forest, heading straight for the viaduct. Hundreds of trees are ripped from their roots, and 11 of the bridge's 20 soaring towers lie twisted on the valley floor. Engineers later confirmed that winds attacked from 3 directions, lifting the towers from their foundations. The original 1882 anchor bolts and the collar coupling assemblies, which mated the old bolts to the later 1900 construction, had failed. Within 30 seconds, nature brought the mighty span to its knees.